So, today we're going to talk about Falco. Yeah, I will explain what Falco is in a few seconds. Before everything else, here with me there's Jason. Both of us are Falco core maintainer and contributors. We basically spend our whole day working on Falco. And so, I mean, hope you all have like a lot of questions for us at the end of the talk. So, what is Falco? Falco in 4 words is Cloud Native Runtime Security, and today we'll probably focus most on the last 2 words of the sentence. So, as a matter of fact, if you think about the previous generation of IT before Cloud Native environment, the most well-known concept about like how to create an IT ecosystem, there was like the data center concept, you know. So, and data center were like kind of like castles, in the sense that the way to defend them was building big, thick walls and make a very small entrance and basically spend all the rest of your time defending that entrance. Of course, the analogy here is with firewalls, IPS, IDS, and that kind of stuff. Well, the point is actually, the reason why I told you it was like the previous generation, because now we are dealing with another generation of IT, which is something more similar to an amusement park. So basically, while previously you wanted to defend your premises as most successfully as possible, today you actually want people to come in. So your IT world now resembles more of a very diffused area, multiple entrances. You don't want to prevent people from entering anymore. Actually, you want people to come in. And you want to welcome them, and you want to let them use your playgrounds, your applications, but still you want to keep your environment safe. So basically, this is the modern cloud environment. You have users, you have multiple touch points. They usually come from web channels. They interact with multiple properties, exactly like an amusement park. And then you have your staff members attending the amusement park as well and operating it. And all this, distributed group of people, you want to keep them safe. So so how do you protect them now? You cannot build walls anymore. You don't want to build walls anymore. You have multiple entrances. The paradigm that we were seeing with the castle doesn't work anymore, actually. So basically, here enters Falco. Today, instead of walls, you want security cameras. So basically, in your amusement park, you try to put the highest number of security cameras in every single angle, have them reporting every security incident or malicious situation or something that triggers a suspicion in real time, and have a centralized point of observation when you can detect anomalies going on. Basically, this is exactly what Falco does. So Falco is a CNCF project. It's the de facto standard in runtime security, which is exactly the term that we use to identify that kind of behavior where you observe and react to malicious threats in real time. So Falco actually was created by Sysdig, the company both of us work for, in 2016. Was donated to the CNCF as a sandbox project in 2018 and reached the incubation stage in 2020. As we speak right now, we are undergoing the due diligence for graduation stage. So hopefully, in a matter of few weeks, we will be able to celebrate something very big for Falco. Thank you. So talking about adoption and usage, this is actually kind of tricky because as a matter of fact, we are running a security tool, so we don't want to build any telemetry into it. So measuring how many users actually run Falco on their own premises is kind of tricky. We do have some proxies on metrics like Docker image downloads, pre-built driver downloads, and a few other metrics that we tend to correlate to understand what's at least the order of magnitude of adoption for Falco. And the last numbers we ran was basically like around 100 million installation of Falco. So it's a pretty big thing that's happening in the Falco community. And as a matter of fact, if someone of you had the opportunity to study for the CKS certification, so the Security for Kubernetes certification, Falco is actually the tool that is presented you. What more? We are growing the Falco ecosystem under 2 points of view. There are end users or adopters, and there are builders. And the reason why it makes a lot of sense into the Falco ecosystem will be clear, hopefully, in a couple of minutes. There are both very big players, even in the community as like end users, either as contributors and as builders. So people that build their own project or products based on top of we provide them with as libraries, open source libraries. Falco basically works in some sort of this way. So the main use case that we have for Falco is that we hook into the kernel in some sort of way. We have like 2 major ways of instrumenting a machine's kernel. We take the data out of the kernel, we bring it to user space, we feed the data into the main Falco application, which is basically a real-time rule engine that evaluates every single event against one or more rule sets and eventually triggers a reaction when something hits against a rule. Today we're going to focus on the first 3 things, and if we rotate them by 90 degrees and zoom in a little bit, it seems something like this. So basically what happens is that below the line there's kernel space, in which we inject either a kernel module or an eBPF program into very specific kernel trace points. We start collecting events. Everything that happens in the kernel basically gets collected by our kernel instrumentation. We bring this huge amount of data. The order of magnitude we are talking about is like from millions to tens of millions of events per second in an averagely loaded machine. We bring this huge amount of data into user space when we see our first interactor is libscap. So we do some collection and aggregation, we decorate with some state in the machine, and then we push everything for Falco to evaluate against the rules. So if we look at a very easy example, I'm sorry for the color, actually suboptimal. So let's pretend you have a C program that actually wants to write the string hello into a specific file handler. What happens behind the curtains in your system is that your C compiler calls the kernel saying, hey, I want to write something, some buffer, into a file descriptor. So basically the kernel does a translation between what you asked it to do and the internal logic of calling his own internals, and actually calls a syscall that is called syswrite. And as soon as this happens, that syscall gets fed into Falco, gets decorated, and gets processed against our rule set. So for example, if you had a syscall that, if you had a rule that doesn't allow you to write that specific file, in this case you would get alerted. And this, of course, extends to all the operation that the kernel does, which is like file system, networking, computation, or whatever, basically. The reason why I was mentioning there's a lot of people that actually doesn't use Falco as an end product, but wants to build on top of Falco is that we, not only we provide the open source community with the Falco binary and all this ecosystem of things that I just mentioned, but we especially separated the 2 main libraries that Falco is built upon, and we provide them as a kind of separate project. Basically, so this enables people to build their own observability solution or their own runtime security solution based on top of the black magic that happens in the kernel that is like enabled by these 2 libraries here. So the reason why we wanted to talk to you, I'm sorry. Before coming to that, this is an example of the grammar that you use to express the concept of runtime rule into your Falco ecosystem. So basically, it's a YAML, piece of YAML file we try to call it like easy grammar. So basically, here I'm saying, hey, whenever there's a spawn process which is into a container, and the binary that gets called is one of the shell processes, I want to get alerted with this kind of output. So this is the message that I want to get, some variables and this kind of stuff, and the priority of the wording. So as a matter of fact, what Falco does is gets the syscall from the kernel, matches against this grammar, and if the thing effectively hits against the rule, there's an alert that gets triggered. Then you can collect the syscall, the alert, and either store into your log system, react in whatever fashion you want to, and that kind of stuff. So actually, the reason why we're here to talk to you about Falco is mostly because there was some major improvement in the Falco architecture in the last months, in which not only we are now able to hook into the kernel, but basically we created what we call the plugin system for Falco. So basically everything, as Jason will talk to you about, can become a stream of events for Falco. So basically we are abstracting away the logic of rule matching and triggering alerts from kernel events to basically everything. Up to you, Jason.
So the idea behind the plugin system is we do have a pretty cool runtime security engine that works well for security, and it's pretty performant because it has to sustain tens of millions of events per second, right? So why not taking the good parts and using that for other use cases as well? So in general, the idea here is to create a little framework for people to create extension of the tool and adapt it to like other use cases than the ones we showed before. So recalling, for example, the architecture that Michele showed, this is how it changes. So basically a plugin for Falco is actually a Falco library plugin. And there are many good reasons to do this, mostly because much of the intellectual property and technology are developed in there, especially the capture library is the one that is responsible for creating and collecting the data stream. So the first thing that plugins can do is actually creating new sources of data, not just system events from the Linux kernel. And the second thing that the other piece of the library, the inspection one, does is extracting meaningful data from those events and enriching that with other information as well. So that then Falco can write the rules with the expressive language and the easy language that you saw before. Plus, many users of the tool do not use Falco, but just the library. So like big players like Red Hat or IBM, they created whole products based on this, and they can leverage the plugin system as well. So again, this allows you to customize the Falco behavior at runtime dynamically, so you can just download the tool plus the plugins and configure them as you prefer and have it running. Since we launched the feature, the use cases of Falco dramatically increased effectively, and the good thing is also that you can develop this stuff in any language you prefer, as long as like it supports a C binding, which most languages do. Now, like how many of you develop in C++ usually? Raise your hand right now. So either most of you are shy or like nobody really likes the language. We are paid to do that full time. So we really know the struggle. And one of the first things that we supported is actually Go, which is much more appreciated lately for some reason. And these are some examples of the first integration that we created. So take, for example, Kubernetes audit logs. So we can connect Falco to a Kubernetes API server, collect all the audit events created when something changes in the cluster, and then we can write runtime security rules on top of that, so that you can be secure on both ways, both on the node and having also knowledge of the whole cluster, all in the same tool. Other notorious ones are, for example, the EKS integration, which is basically still like the Kubernetes one, but with a special attention for the offerings from Amazon. Talking about Amazon, one of the biggest one is AWS CloudTrail. So every time something changes or someone does something in your infrastructure in AWS, Falco is able to collect that event and write security rules on top of that. There are others. This is just some of the officials that we support. A funny one is actually Okta, because take, for example, the Uber breach that happened in fall 2022. Now, this will have not prevented that, but people will have been able to actually be noticed about something that was about to happen much faster than actually what the story told us. So at the end of the day, Falco is runtime security. If you add the cherry on the cake of plugins, you can actually use that not just for the system kind of events, but basically everything you prefer. Now, why such a big deal for the specific use case of cloud events, right? Nobody really, I mean, you may think, why just cloud services, cloud platforms? And the main reason why is that it is sort of much more convenient than the alternative in most cases. Because, for example, what happens in those environments is that they're just too dynamic. So a lot of stuff happens, and usually what a service does is just creating a security event, an audit event, allows you to hook it up in a pipeline so that you can store it, and then do like sophisticated analysis later in case of incident or like periodically. But there are 2 points here. One is that in case of incident, your response is delayed. It takes time for you to actually do the analysis and in non-predictable times maybe. Plus, you have to pay the cost of that storage. And sometimes when you have like a big infrastructure, a lot of services running, this is actually a good piece of the bill, basically. So take, for example, the AWS CloudTrail use case that I showed before. This is how you can imagine it to work, basically. So let's say that there is like a very bad hacker that wants to do something bad in your infrastructure, and they're able to, right? We are not able to block him for some reason. So if you enable CloudTrail in your AWS infra, that will generate an audit event. And the thing you can do with that event is, like before, store that, and eventually do some inspection, pay someone or a team to do that, and eventually discover if something went bad, what went bad. And you can still do that. Like that, I mean, we don't substitute that use case. But at the same time, now you also have the cheaper option, all open source, all for free, to just pipe that into CloudTrail, connect that to Falco, and have that sort of detection at runtime, in real time, in a matter of seconds, when the event is happening. You can just write a rule like the one that Michele showed before. The language is always the same. Now, that is a pretty oversimplification of how a rule like that works. That's pretty naive, but it's there just for the concept. So that's way cheaper because it doesn't require a long retention of logs, and it gives you like immediate response. So how can you get involved? How can you help? This is an open source project, so like there is a role for you all as well. We have documentation both for the high-level stuff and the technical details as well. We do provide out-of-the-box SDK that you can play with for, so far, just for Go, production ready. We are also have something in the working for C++, and there are initiatives to do that for other languages as well. There's one guy working on a C# one for unknown reasons, which we lost track of, but it is happening, definitely. If there are any Rust enthusiasts, you're welcome to actually start and help us in this. What we also have is like an official registry, which is like a big container of metadata for the plugins, either the ones maintained by us in the community and the private ones for the users, which basically allow us to coordinate on the technical details. Now, we miss still something in the whole picture, which is, what do you do with Falco Alerts when you receive like a security event? Okay, the output framework is pretty elastic, but there has to be a destination, right? And we provide that for sure. Meet Sidekick. There's a gopher in there because it was developed in Go. I'm no author of the icon, so I cannot say, but basically it is a tool that allows you to integrate with many other services. Good examples are chat systems, logs, queue systems, or serverless operations, if you prefer. So Sidekick basically collects the alerts from many of your Falcos. So basically, if you have one per node in your cluster, there's usually just one Sidekick for those. And then it pushes that information in a fan-out way to all the outputs that you want. You can do smart stuff as well, like routing, depending on the priority, collect metrics, data, and then use that to do like extra reasoning. A pretty good thing to mention is like if you are into serverless stuff, you can create an end-to-end, event-driven workflow for security, all for free, basically, because Falco can do the detection. Sidekick can collect all your Falcos in your fleet, and then push that information and messages to, I don't know, AWS Lambda or something, so that when you have a security event, you can also react. And if you take an example like the AWS infrastructure from before, everything can happen in your infrastructure without your data ever leaving, in this case. So it's a pretty convenient thing to do. Last but not least, we are a pretty open community. People are friendly, I can assure you. You can find us, of course, on GitHub. But we also discuss plenty of stuff in Slack. There are news feeds, especially on Twitter and on the mailing list. We meet every week on Wednesday, so feel free to actually reach out and say hi if you want. And this is an open source conference, so if you're looking for opportunities to actually write some code and create a pull request, like this is a pretty good place. There's space for both system programmers and also like people more liking cloud stuff, let's say. And this is it. Hopefully there are any questions. Please don't be shy.
Thank you, guys. So big round of applause for them. Thank you for joining us here, guys.
We forgot about a major point. If for any one of you attending KubeCon Europe, we will be there. So please pass by. We can grab coffee together if you want.
Great. So allow me and the team of Schrodinger's Set and all the volunteers to kind of give you this prize trophy about Schrodinger's Open Source Day. It's 3D printed with sustainable materials. That's very important.
Thank you so much.
And please take care of this. They're important for us.
I will,
right?
I promise.
It took like 15 hours for each. Like 1 month ago we started building the. No, to actually build it. Like it was insane. So. Any questions from the crowd? I've seen one over there.
Yeah, so thank you.
Pronto?
So, okay. Thank you. Falco looks like a great product, so I wish you all the best of luck. And I want to ask, what kind of plugins do you expect the users to write? What is like use case for plugins?
New ones, you mean?
Yes.
The biggest demand that we have is other cloud providers. So like I showed you, the one from Amazon, there's people demanding for GCP and Azure as well, of course, and the built-in integration for Kubernetes data as well for the managed offerings, let's say. There's some people working on it, but it's not structured. So again, an opportunity here.
Okay, but so at the moment there is only Go SDKs?
There is the Go
so
SDK.
C++?
If you want to, I mean, the C++ SDK, it is working, but the reason why I'm not advertising that as production ready is that we're still trying to improve it. But
I think that's an opportunity right there.
Yeah, that's an
right?
It's not that hard, by the way. It's like 20 C symbols. The biggest concern is performance. So there's plenty of black magic happening down there. But we can start for something simple if you want like another language to, to work with.
Okay, thank you.
Great, thank you. Any other questions in the room? Let me see, I'm scouting the room. Yeah, we have one, Nicola. Right there.
Hi, Francesco. Good presentation, nice product. It seems to me that this is an example of mature product and great product, that it's amazing. And open source, you quoted many times that is part of the CNCF, also graduation, blah, blah, blah. Okay, but I assume you are employees, for example, Sidekick, okay? So you of course you have a salary, of course everything is for free. So how this mature project guarantee the sustainability? So what's the business model apart from the free and open source offering?
Can I get like a couple more hours?
Okay.
Yes,
If it's too long, we can take it offline.
You can.
No, so it's very simple actually. So first of all, our greatest effort in the last couple of years has been to detach Falco from being like maintained just by Sidekick. So we invested a lot on maintainer diversity. There's actually like a very diverse set of maintainers contributing to Falco every single day. And you were talking about the business model. So I think the translation of that was like, why Sidekick is putting money into that, or something similar. So the take is actually Sidekick provides a commercial SaaS offering that is based on top of Falco. So Falco is one of the major building blocks of the commercial solution. So while we do believe there is, so Sidekick actually has a pretty consistent open source posture, and Falco is one of the biggest differentiator we have compared to the competition. And while we try to keep that separate, in business operations. So open source is a totally different organizational structure and that kind of stuff to guarantee, independence. There is commercial interest by Sidekick in building the main product that we sell actually, which is, again, Falco is the main building block for that. Does it answer your question? Okay.
If I can jump in, for other companies to jump in and contribute to the project without, you have to create a business interest, I think. So many of the biggest players that we have among our contributors are people that actually love the technical value of the project, starting using that and probably realize that it's more expensive to recreate that from scratch instead of helping us improving it. And that has been paying the dividends over at least the past year. I'm in the community since 1.5 years. So since then, I saw a big jump in people jumping in, even opening just one PR or helping with the documentation. But there's plenty of vibe right now. So there is interest, not just from us.
Thank you. Thank you very much, guys. We have another question. Great.
Thank you. Great product. Before I will check the documentation, and I'm sure I do, have you think about any integration with artificial intelligence? Because when you're talking about runtime, it's good to have some kind of intelligence behind the scenes.
There is a girl from Apple, which became maintainer recently, which is a big security enthusiast, and that's one of the topics that she brought to me in a call, for example. The biggest opinion that we have is the more you put in the tool, in the middle layer or even collection from the system, the worse it is, because the more work you have to do, the slower the tool gets, and you basically lose the visibility. So what actually can happen is that you create alerts, maybe a little bit more noisy, let's say, and then collect all the data in a different place, and then doing analysis. And there are people, I think, creating automated system out of this. We're not that people in open source, but I heard about this a couple of times. So at the end of the day, it's an event-driven model, and you have plenty of data to work with. So if you're into AI, that's the kind of deal you want to play with.
So as a matter of fact, what happens, usually with the Falco pattern, you do these kind of things downstream, the pipeline. Exactly. We try to be as much atomic as possible to guarantee performance and consistency of the data that we extract. So the people around the community that do this kind of stuff, they do that as a output channel from the Sidekick implementation that Jason showed before. But yeah, there's a lot of interest in that as well. Yeah.
Thank you very much. More questions? Great. So we're on schedule, so that was great. Thank you very much, guys. Big round of applause for them.